Okay, hello everyone. I welcome to all in our lecture series on laser physics. In this lecture series, we are discussing these topics. In our previous classes, we already discussed these topics in detail with note. We discussed Ruby laser. Last class, we discussed Nd:YAG laser, construction, working and applications in detail with note. In this class, we are going to discuss helium neon laser, construction, working and applications. Okay, so let us start. Last class, we discussed Nd:YAG laser, its construction, working and applications in detail with note. In this class, we are going to discuss helium neon laser, which is a 4-level laser system. Okay, and this is widely used in all over the world, which operates at the wavelength 632.8 nanometer. In a red part of the visible spectrum, it is a red, it looks like red, and it is invented by Javan ETL around 1961. Here is the construction. The helium neon laser consists a long, narrow discharge tube having diameter 2 to 8 mm and length 10 to 100 cm. So its diameter around 2 to 8 millimeter and length is your 10 to 100 cm can be vary this length. Okay, and this is a glass tube or the so-called discharge tube, which is filled with helium and neon gas with a low pressure around 0.1 torr. The mixture of helium and neon gas approximately 10:1 ratio. This is important point that you have to write in your exam. Helium is to neon ratio 10:1. So helium is large amount as compared with neon. With electrical pumping by high voltage electric discharge, helium atoms will be excited. So here helium atom act as the active material which will be provides the laser action. This ratio is the most important for this topic. If this question will be asked for 3 to 4 marks, whatever I am going to discuss in this class, it is enough. This note is enough. But this point is most important. Helium to neon ratio is your 10:1. The excited helium atoms collide with neon atom. Hence, some of the neon atom will excited and provides the laser action around 6.32.8 or around 633 nanometer wavelength. So this is all about the construction. This is the glass tube. In between the glass tube, it is filled with helium neon gas, where helium is 10 is to neon is the 1 ratio. And this side is highly reflecting mirror, and this side is your partially reflecting mirror. Obviously, it will be act as a resonator cavity, and this gas will be discharged by electrical discharge method. So here we are going to give a electrical energy through the anode and cathode. Now we are going to go for the working. Due to electrical pumping, as I told, which one is the lighter? Lighter is the obviously helium. Helium atom easily get excited by electron collision to either 3s or 1s state. So helium atom, as it is lighter, due to pumping by electrical method, it is excited to either this state or this state. Okay. Now we are going to consider neon atoms and its corresponding energy levels. So this is the 3s energy level of neon, this is 3p, this is 4s, this is 5s level, and this is 4p level of the neon atom. Here you can see this level and this level, 4s level is equivalent height as compared with the s1, and 5s is equivalent height to the one, sorry, this is 3s and 1s level. So 1s is equivalent to 5s, 3s is equivalent to 4s. So whatever the helium is excited to here 3s state, as this level and this energy level is comparatively same, so easily this helium atom can provide the energy to the neon atom, which can be excited directly this state. Got it? So helium atom which are excited to 3s1 3s state, this level, this energy level is exactly matched with the 4s level of this neon atom. So obviously this energy, whatever the helium atom have the energy in this state, that entire energy will be provided or will be transferred to the neon atom by the collision, and neon atom will be excited to the 4s level. Likewise, the helium atom will be here. Suppose whatever the energy the helium atom have in this state easily transferred to the neon atom, and this neon atom will be excited to the 5s level by the so-called elastic collision, inelastic collision between helium and neon. Right, same thing it has been written. Electron collision. Due to electron collision, helium atom collided with electrons. That means due to discharge method, electron is collided to helium. Helium is excited. This symbol, star symbol, represents the excited helium atom. So here helium is there, means this one, helium excited, like this. Now this excited helium atom transferred its energy to neon by collision, and helium atom will be transit to ground state, and corresponding neon atom will be excited to 4s level. This one, this reaction tells about this dynamics. So helium atom first taken the electron, it is excited to this level, 3s level. As this 3s is compared with 4s, so obviously this total energy transferred to this neon atom, and neon atom will be excited to this 4s level by through the collision. Same thing it has been written. The excited level helium atom and neon atom are comparatively same. Here this one comparatively same. Hence excited helium atoms transfer all energy to neon atom which are in the ground state by collision elastically. As the result, neon atoms can excite to 5s and 4s energy levels. What I explained. Since the pressure of helium atom is 10 times that of the neon, the level for 5s and 4s are selectively populated as compared to other level of neon. So no matter here, as obviously the pressure of helium atom, as helium is your 10:1 ratio, so obviously helium atom pressure will be 10 times more than that of the neon, due to which the level 5s, this one, and 4s of neon are selectively populated, because whatever the helium will be excited, that will be transformed to the neon, no? So if helium will be excited to these two levels, so these two levels energy will be transferred to the neon. So obviously neon atom, most of the neon atom, almost all neon atom will be excited to this level and this level. Okay, these are the excited neon atoms, right? Now then we can get different transitions. Here transition from 5s to 4p, here this one, 5s to 4p, this transition have the wavelength is how much? 3.39 micrometer, is a infrared, incoherent. Incoherent means not laser. It is a infrared light or infrared energy, electromagnetic energy we can found due to this transition, which is not a laser action. Then we are going to consider transition from 4s to 3p. Here 4s to 3p, this transition having wavelength 1.15 micrometer, it is nothing but also infrared, and it is also incoherent. We could not found any laser action. This is also incoherent. Transition from 5s to 3p, here 5s to 3p, this transition 5s to 3p, 5s to 3p having the wavelength around 3633 nanometer, which is in the visible red light. This transition gives the coherent photon beams. So coherent photon beams means so-called laser action or stimulated emission. That means mostly population inversion can be found between these two levels. Okay, these two levels. So stimulated emission happens in between these two levels, 5s and 3p, due to which we can found the laser action and having the wavelength around 633 nanometer or in the visible range. Okay, now another transition 3p to 3s, which is a fast radiative transition, or we can say spontaneous radiation itself, which is a fast radiative spontaneous transition. Fast radiative spontaneous transition, obviously it is not a laser action. Then 3s to ground level by non-radiative transition, or you can say de-excitation by collision with walls. So after coming to this 3s level, the neon atoms will be collide with the wall of this gas chamber, and it will be de-excite to the ground level by non-radiative transition. Only it will be diffused to the wall or de-excitation by collision with the wall, and it will come down to ground state. Again, same procedure will happen. Helium will be collide with neon will be excite and de-excite by various transitions, but mostly population inversion is created in between these two levels, and we can found the laser action, this one 6328.8 or around 633 nanometer. Okay, so this is all about the helium neon laser. This is the application of helium neon laser. The narrow red beam helium neon laser is used to supermarkets to read barcode. So helium neon laser used in the market to reading the barcodes. Helium neon laser used in holography itself to producing 3D images of the objects. Helium neon laser having many industrial and scientific uses and often used in laboratory and demonstration of the optics. So these are the main applications of the helium neon laser. Thank you so much for watching this video. In our next class, we are going to discuss semiconductor diode laser, which is a two-level laser system. Okay. So thank you so much for watching this video. Thank you.